Welcome back to Wickerson Studios. My name is Michael Wickerson, and I'm continuing with the third chapter of the One-Liners ghPython book, which is based on data science. So with that, you're going to have to start importing things like NumPy, and I've found a way to go in. I showed this on the last video, but I can answer it more specifically into downloading Anaconda, which happens to be the one I'm using, to bring in the ghPython remote node. It's a little more complex than bringing in regular nodes or regular plugins. So please follow through kind of the guidelines and see if that's something that you want to do. And if so, you can start writing scripts like this. And you can see with this remote ghPython node, which is here in the Maths tab, you get this kind of like remote signal on it, the ghPython remote. To an external Python instance, and there's the instance over here of the one-liner intermediate tree helper, because this is the script I'm using out of the text, and it works just fine. It does say it works in Rhino 6 only, but it seems to work fine in generating the data over here, and it's got a bunch of jazzy new things in it. So I'm kind of taking a little bit of a leap forward, and I'll have to take a few steps back to find out where I was. But you see what's happening. You're regularly importing your RhinoScript syntax, but if you bring in and find your location on your computer where Rhino remote is, and you set this to true, and you put in the module NumPy, you should have very few problems. You can see over here, I have linked modules coming up, NumPy, which is nice, so that's actually working now. This one's running RPY, which I put in as an added output to see if it was running, and import statements, that's the import statement that it's actually trying to run, and that's coming from this script. So what I've done is imported script context, which is important, as SC, and then I've imported Rhino remote, which I could have done as RG or something like that, but I didn't. So I don't mind typing it in. So from the ghPython library tree helpers, that was another one, I'm going to import list to tree, and then NP is going to be script context.sticky NumPy, and then I'm able to use script context sticky NumPy by arranging a range function, reshape it to X and Y, and you can see what's happening here is I'm generating a very interesting tree. And A will then be the ghPython remote obtaining the A2 list, which is, I guess, grabbing the NumPy, and then I'm creating the list tree A source equals to 0, 0. Now, I haven't played with those numbers too much to see what happens when I start to change these hard-coded numbers, and I'm a little nervous to do that in front of you, but I'll do it because this is new to me. And we're going to backtrack up and do some very simple basic 2D array arithmetic, which is something I haven't done since I was like in grade 10, 30 years ago. And we'll look into the basics. So let's just slide this around. You can see that I can change that to have 2 branches. I can go up and have 3 branches. I can have 4 branches, whatever I want. Let's leave it at 3. And then I can split those branches from the number. And because they're indices values, it's best, I found a way to just multiply for the range an integer that will come in because it's just a multiplication of these 2 numbers. So whatever these 2 numbers be, that's going to change the outcome of how many you want. So if you want 8, now it's going to divide it into 3 groups. And if you want which is actually 9 if you think about it, because the range has +1, so 8 is going to be actually a 9, which divides evenly into 3, so you'll have 3 groups of 3. 4 will be 12, which will be 3 groups of 4. 5 will be whatever that ends up being, 3 groups of 5. And if you want to change this again back down to 2, and you have 2 groups, but if you want to split them up into more groups, obviously you have to find factors. And it's another cool way to find factors. This isn't going to change at all, except for 3. Set at 5, it's only going to be a group of 1, 2, or 3, because that's what those are the multiples within that. So if we go to 4, we're going to be able to change from 0 to 1 to 2 to 3 and to 4 and even to 5, which is nice because you've got 20 as the number that you're playing with. So 4 groups of 5 and 6, 7, 8, 9, 10 aren't going to do. What are those doing? Those are starting to pump up divisions of 4 into 40 because we've got 4 groups of 10. So that's it. You're just adding groups as you go of 4. So a very nice little tool for making some very cool trees dealing with the factors of numbers. And I hope you find that helpful. I will be downsizing this and going back and on all this jazz, which is a little new to me. But I will get hard into data science and we will have a wonderful time together. Thanks for